Hey everyone, my name is Sam, and I'm a PhD student at the University of California in San Diego. I'm going to be presenting work today called Codehound, which helps instructors track pedagogical code dependencies in course materials. When we think about teaching, the image that often first comes to mind is standing in front of a classroom with a room full of students, and we think about the act of giving a lecture to students or to learners. But in reality, teaching has a great deal of behind-the-scenes work. As anyone who has taught a class knows, teaching is not only just speaking to students in a classroom, but also preparing all the educational material that students need to use to learn effectively. One challenge is that these course materials have intricate dependencies. So in a typical technical course, for example, in a programming class, a single week's worth of material might have a lecture with slides and video. We might use discussion worksheets, which also use code, a lab that students will also fill in using code, and homework, which may have code and plots and other free-form responses to grade. One challenge with these materials is that they depend on each other. So the material in discussion is supposed to reinforce the material in lecture. The material in homework is supposed to reinforce the material in the rest of the material for that particular week. When an instructor needs to update a single slide in a lecture, that may have implications for motivating them to update the rest of the material for that week to match. So if they change this particular slide, they may need to make sure that the discussion worksheets, the lab, and the homework all stay up to date with the current lecture. This sort of dependency is not only occurs within a course, but within a week, but also between weeks. So in a single week, a course may have multiple pieces of content and multiple pieces of material, but these dependencies also depend between weeks as well. So the material in week 4 is meant to reinforce the content in week 2 and vice versa. In other words, these pedagogical dependencies, concepts that are introduced in previous weeks, are meant to be reinforced in later weeks of the course, and it's up to the instructor to manually go through their course materials to make sure that everything is up to date and reinforcing each other. Instructors do this by going through their course materials one file at a time, opening their slides, opening their code and scripts, and making sure that all their materials stay consistent. And it's a manual process that the instructors must do as well as their course staff. I encountered this issue firsthand while working on a textbook for data science. And for example, we want to ask a question. This example is kind of long in our book. Maybe we can take it out. And we encountered a discussion where another instructor or another co-writer on this book asked, wait, don't we use this example in 3 weeks? Well, we're not really sure. We have to go back through the book and check. So these pedagogical dependencies are a core part of teaching. We want a material to reinforce what happened before, and this process must be done manually. We check each file one by one. So within a course, we might have multiple weeks of material, and our instructor's question is, what do students know at this point in the course? In week 5 of the course, what can I introduce to students that is not too new, that it will go over students' heads, but it's also not too simple, not just a repetition of what students have already seen. This sort of question occurs not only within a course, but also within learning materials in general. So this is a course of data science, but it also can occur working on other types of content like a textbook. I worked on a textbook with multiple co-authors, which is commonly the case for teaching. We have collaborators and people that we need to coordinate with. And in this case, for example, one of the authors worked on chapter 1, another author worked on chapter 2, and I was working on chapters 7 and 8. And one challenge that we encountered while working on this piece of material was whenever someone changed the content or code in chapters 1 and 2, I needed to make sure that these changes were also reflected in chapter 7. So we're asking the question again, what do students know at this point in the book? And we can replace the textbook with other types of educational content, ranging from blog posts, ranging from lecture notes and materials to all the content that are used in courses today. And so one inspiration for this work is that IDEs, or developer tools, provide tools for code refactoring. So for example, in my code editor, I can ask my editor to change the name of this variable, and the editor will automatically update all the references to that particular variable across all of my files. This is a process that I would have had to do manually. I would have had to go through my files and update the names. If I rename this variable, I have to go through the rest of my files and rename them myself manually. But with the automatic tool, this can be done for me, and it automates away this sort of tedious individual file by file like checking. And so what we're trying to do with this project is bring this idea into teaching, into the materials that we use. The question that we're trying to ask is, how can a tool support lesson refactoring? So as instructors update and change their course materials, how can automatic tools support this process so that instructors can focus on the content rather than making sure that all logistical details of the files are up to date? To address this need, we developed a tool called Codehound. And this talk will cover the system design and implementation of this tool. I'll present 3 usage scenarios that illustrate, that walk through a real-life example of using the tool in a classroom setting. And I'll point a vision towards courseware engineering, or tools that can kind of point the future towards how instructors can collaborate with software to meet their needs. Okay. So Codehound is implemented as a sidebar in Jupyter Lab. As an instructor, data science instructors or programming instructors use an interface called Jupyter Notebooks to write their code. So instructors can write written content, they can write code and execute the code. And this is a relatively common format that's used by instructors to teach students how to code. What we've done is we added a sidebar to this interface. And so as instructors create their slides and their homeworks and their labs in Jupyter Notebooks, what they can do is open Codehound on the side. This sidebar displays newly introduced methods in this piece of material. So for example, this particular notebook introduces grouping, which is a data table operation. And what this sidebar shows the instructor is that in this particular piece of content, the group by method is used for the first time. The reset index method is used for the first time to students, and the two-frame method is used for the first time to students. So it's an indicator to the instructor that, okay, in this notebook, students have not seen these lesson methods before. I should make sure that I introduce them when I teach my class. So at a glance, instructors can immediately see what methods students have not seen at this point in the course, and they can make sure that these methods are properly introduced. This sidebar updates live, so when an instructor updates their code in this particular lecture, the sidebar method list will also update automatically. So here's an example. So here, the instructor adds a call to sort values. And since this is the first time the sort values method is used in the course, it appears in the right-hand sidebar of Codehound. Likewise, when the instructor uses the method groupBy, the groupBy method also appears since this is the first point in the course at which students will have seen the groupBy call. However, students have already seen the sum method call, so when the instructor runs this code and saves it, it doesn't show up in the right-hand sidebar since students have already seen the sum method at an earlier point in the course. So it only shows, by default, newly introduced methods and hides old previously introduced methods away. If an instructor does want to show those old previously used methods, they can click the check marks and it'll hide and toggle off and on new versus old. Another feature of Codehound is if the instructor clicks on a method call in the sidebar, it will display the list of other files in their course or the piece of material that uses the call. So in this case, this is a screenshot from a textbook I'm working on. And when I click the groupBy call in the sidebar, it shows to me, okay, in chapter 6, groupBy was used quite a bit, but also in chapter 9 and also in chapter 10, I can scroll down the sidebar to see every single file in the book that uses the groupBy method call. This also works in course materials. So instead of a book having chapters, we can imagine a course having weeks. So instead of chapter 6, we can imagine week 2 of a course, or week 3 of a course, or week 4 of a course, and so on. Codehound is implemented as a TypeScript extension to JupyterLab. And what it does is the instructor needs to give Codehound an ordered list of files used in the course. Typically, instructors already do this work when they're making their syllabi for their course. So on a course website, I might list out on week 1, we cover 3 lectures and a homework and a lab. And in week 2, I do 2 lectures and maybe like another homework and a project. And so instructors are already doing this work to tell students what material that they're going to present at each week in the course. And so this order list of files, right now Codehound reads it, the instructor has to input this order list of files in a YAML data file to Codehound. But in the future, Codehound could relatively easily scrape this information from the course website, for example, from a course. So instructor needs to give Codehound an ordered list of files used in the course. And what Codehound will do is it will take the code used in all of these files, and it will parse the code. So we'll parse the code into a concrete syntax tree and pull out all the method calls that are used within each file. And what that gives us is an ordered list of function calls used in the course. And the key idea here is that if the function hasn't appeared before in the ordered list of function calls used in the course, then it's a new function to students. So if in lecture 2 I use group by, but I haven't used it yet in lecture 1 or homework 1, then to the students going through the course, lecture 2 is the first time they've seen the group by method call, and Codehound can automatically detect this since the method call has not been used in prior pieces of material. I have to gloss over a couple of details in the interest of time, but this list automatically updates when instructors update material. When instructor updates their content, what we'll do is we'll reparse their code and then update this list of function calls so that this order list of function calls always matches the instructor's current version of the material. Okay. Next, I'll run through 3 usage scenarios that are drawn from real-life experience teaching courses about how Codehound can help instructors do their work. If the instructor wants to create new content, they often want to be alerted to when they're using methods that students haven't seen before. So in this example, the instructor is using the melt method for the first time. And when they write the code that uses .melt, Codehound will display melt in the sidebar, letting the instructor know that the melt method hasn't been used before and it should be introduced. Now, when the instructor uses the tail method, on the other hand, this method has been introduced at an earlier point in the course, and then it gets hidden in the sidebar. So the instructor here knows that, okay, as I'm making this lecture, students have not seen the melt method, but they have seen the tail method. During my lecture, I should make sure that I go over the melt method and explain what it does, but I don't need to give such a thorough introduction to the tail method since students have seen that at earlier points in the course. Now, on the flip side, if, on the other hand, the instructor sees that the tail method here appears in the sidebar, they might say to themselves, oh, I actually meant to introduce the tail method earlier in the course. This method was supposed to appear in week 1 or week 2 of my course, and I forgot to introduce it in my earlier pieces of material. So now the instructor doesn't have to go back through all of their lecture slides and lecture notebooks to understand whether tail or melt had been used before. This work is being done automatically, and instructors can use that information to make their course better. Instructors often update their course materials to try to improve the quality of learning for their students. And one update that happens is reordering materials. So if the instructor decides, I have a function here and I want to introduce it later on in the course, what instructor would have to do now is move the function into a later lecture and then manually go through their notebooks and their homeworks and their labs and their discussion worksheets to make sure that this function doesn't appear where it's not supposed to. So you have to manually go through and check each file one by one. With Codehound, what we can do is move the descent function later into, let's say, week 8, and then Codehound will display an ordered list of files that use this function call. So when the instructor clicks on the descent function in the Codehound sidebar, they'll see, okay, descent is introduced here in week 8, but now I have these files up here, week 6 and week 7, that also use descent. And I need to make sure that these specific files get updated so that they no longer reference the descent function. They can also use this to delegate work to their staff. So they can ask their TAs, hey, can you go update these 4 files, these 5 files specifically to make sure the descent function is no longer used. And after the TAs are finished with their work, the instructor can then verify that TAs did their work successfully by making sure that the descent function only appears for the first time in week 8. And lastly, instructors sometimes want to trim content out of their course. And so here the instructor asks, this pivot table function is relatively complicated, confusing the students, perhaps, and maybe they're considering removing this function from their course. But then they want to know, if I actually take out this function from my course, how hard will it be to actually update all of my course materials to make sure that this update is good? And they want to know, is this change going to be a long process or a short process? So in other words, if I take out pivot table from this particular lecture, how many other pieces of material need to change in order for this to be pedagogically successful? So what the instructor can do is click on the pivot table function in the Codehound sidebar. And when they do so, they can see that only 2 other files use pivot table, and they can kind of breathe a sigh of relief and say, okay, if I take this out, I actually only need to update 2 files in my course. I don't have to go through and ask a whole team of my staff to run through the entire course materials. So to me, Codehound is an example of a broader vision of tools that I like to call courseware engineering. For example, we can extend Codehound's approach by thinking about how we can amplify the parsing and the analysis that Codehound applies to these files. So right now, the Codehound analysis is relatively simple. It parses out all the function calls used in these lecture materials. But with parsing tools, we can also extract out different types of programming constructs. So instead of just function calls, we might also be interested in idioms or sampling schemes, things that involve multiple lines of code instead of just single methods at a time. For example, in data science, when we talk about sampling using a simple random sample scheme or a stratified sample scheme, and what Codehound, a future version of Codehound might be able to do is apply like more general program analysis techniques to extract out higher level ideas within code and not just single function calls themselves. Another idea is to use runtime analysis. So instead of just analyzing the code and parsing it, we can execute the code. And this, for example, will allow us to say, okay, in these lectures, we use these particular data sets, and we can analyze how they were processed through lecture notebooks. One drawback, one limitation of the current version of Codehound is that these files here that Codehound analyzes all have to be Jupyter notebooks. But in a real course, code lives in multiple types of files and applications. So we have code that appears in our lecture slides. We have code that appears in our LaTeX-generated PDFs. And we would like to make sure that all of that code remains consistent across the course. So a future version of Codehound can also extract out code across files and applications from lecture slides and PDF worksheets and make sure that all of that is consistent for the instructor. So Codehound, what we're doing here is we're drawing inspiration from developer tools. So when working on large software projects, developers have access to a wide range of tools to support their work. For example, I alluded to the idea of refactoring tools that allow software developers to, for instance, rename a variable and have that update reflected across all their course material. There are, of course, other ideas from software engineering that we can draw into the classroom. So one idea that we have is to use code coverage to draw an analogy between code coverage tools, which tell the developer This particular file has lines of code that your test cases do not address. And you should write test cases to make sure that this code is tested. We might take this idea back into the classroom by talking about concept coverage. So in a lecture, we might introduce new ideas, and we want to make sure that all of these ideas are reinforced by the homework and the lab for that particular week. If an idea from lecture isn't covered in the homework or lab, then the instructor might consider removing that from the course, or they might want to make sure that this idea is covered. Another idea is when working on large software projects, developer tools will pull up inline documentation, so you can quickly see this method has 3 arguments, and these are what the 3 arguments do. And for students, oftentimes what's more relevant is drawing from examples from previously seen course material. So instead of pulling up a little dialogue just showing the method call and its arguments, students might benefit from seeing examples from past lectures or past homeworks that they've worked on themselves. So the idea here is there's a wide range of tools available for professional software developers to do their work. At the moment, the set of tools available specifically designed for instructor use is relatively limited, and Codehound is trying to provide a step forward into a set of tools that instructors like us can use to teach effectively and to focus on the most important thing, which is making sure that our material is pedagogically sound and useful for learning. So in this talk, we've talked about the inspiration and motivation for Codehound. I presented to you the system itself, its design and implementation. I've run through some user examples for the tool, and I talked about a vision for courseware engineering. This concludes my talk. Thanks for listening, and I really appreciate it, and I'll take questions now. Thank you.
Thanks, Sam. Oh, I wanted to just give a little bit of logistics, which is, Sam, you can call on questions in the room, but I also want to make sure that we can answer some virtual questions. So, but feel free to call on the question in the room, and then I think Martin has a question virtually. If you're a virtual participant, feel free to put questions in the chat or Q&A.
Perfect. Molly, should I switch back to AirMeet to see?
That would be great, sure.
Okay, thanks. I made a question in the back in the room. Hey, yes, what's your question?
Well, hello, thank you. Yes, I'd like to ask about whether your tool supports a less linear sequence. Sometimes students take their own path through materials. How would you anticipate coping with that kind of behavior?
Yeah, it's a great question. So the question is, this tool right now kind of bakes in the assumption that every file will be presented one at a time in a predetermined order. And students sometimes jump around between material. How can we support that? And I think that right now, this sort of dependency tracking is done automatically via developer tools. So in software projects, we may have one file that's referenced by multiple other files, which is then referenced in kind of like a tree of file dependencies in a software project. And so I can see a similar idea applying here for Codehound as students work through material. I think that it might be, like, as of right now, I'm a little unclear about how that might actually play out in terms of the interface and how that interaction might work. But I think it's a good idea, one that could feasibly be imported from software engineering. Thank you. Another question in the back, yes.
Yeah, this is a great tool for handling code and things where we have the kinds of precise distinctions and the traceability that we get, and I think you did a great job of building it on software developer tools. There's a lot of other material in courses, though, and you need some examples where you want to draw an example from the code base and throw it up in a lecture, and then there are concepts that are not quite as crisp to trace because conceptual dependencies are much harder to document with code things. So I wonder what the balance is between pushing on this technology that is rooted in code development and drawing on an alternate approach to management, which is content management systems for websites. So websites offer you hyperlinks so that you don't have to linearize the materials. The content management systems allow you to identify a definitive version of something and then propagate it to all the other places that it needs to be. It's a little different from the code development environment, which is kind of bottom up. You've got the code and you find the structure. The content management system gives you the structure and propagates things down. And I wondered if you had thought about how these interact with each other and whether there are some things that are appropriate for content management systems and some things that are more appropriate for the code development model.
Yeah, it's a great question. So I'm trying to decide, I'm trying to understand the question. So the question is about can we take ideas from content management, or how does content management systems contrast with the approach taken here?
Yeah, both of those.
Okay.
What are their relative strengths and weaknesses? Mm-hmm. And in your overall objective of engineering for educational purposes, what is the role of content management systems in a complementary way to the development systems that you started with?
Yeah, okay. It's a really deep question. One I don't think I can sufficiently answer with the limited time I have. My gut reaction is that content management systems work wonderfully for instructors when their structure is when the structure is relatively refined, so it doesn't involve a whole lot of moving content around. And maybe one challenge that I've had while working with content management systems is making sure that not only that my content management platform has to be up to date, but also now my code files also need to reflect the content management system. So for me, I think that there is a possibility here to take the structure from a content management system and kind of impose that onto files themselves, which inherently don't have a hierarchical or ordered structure. And maybe there's opportunity here to take, instead of having instructors input to Codehound a linear list of materials, they can input to Codehound maybe their content management system's database and have that impose a structure on their files and their ordering.
Sam, could I interject for a second? One is just a note, in that case you did enough repeating, but just for speakers in the room to repeat the question because the microphone's at the start. And I'm wondering if you could field one virtual question, and then we have a bunch of others, which maybe you can respond to on AirMeet, but then we'll have to transition to our second talk. I'll go with Dennis's question, which is, when teaching APIs, some new API functions are very similar to previously presented ones, but others are totally different to what they have used before. Do you have any thoughts on this? Does this pose an issue? How might Codehound respond?
Yeah, it's a great question, and one that I've actually thought about while working on this tool. One thing you may have noticed during the presentation is that the arguments are also displayed alongside the function call in Codehound's sidebar. And what the idea behind that was to actually handle that case where if you change the argument of a function call, you may end up with a very different behavior than the original function call itself, by default. And so as of right now, I don't think I have an excellent way to handle that, since arguments also have different types, and each type of argument, when you change a type of argument, that also changes the behavior, but maybe not in significant enough ways to warrant noting it as a totally new idea for students. So I think it's a great question, and one that I'm venturing into myself. I don't have a really excellent, precise answer for it, but I do think it's important, and I'm happy to discuss with you examples for how we can tackle it in the future.
Awesome, thanks. Let's thank our speaker again.
Thank you.